So the next speakers, actually it's a couple of speakers who have played a big role in attention and number. They are Martin Fischer and Samuel Shaki, cultural and conceptual aspects of SNARC.
So good morning, everybody. I will share the talk with Martin Fischer. So I will start with reviewing our cultural and cross-cultural studies. And then Martin will continue with the conceptual aspects of the SNARC. So I will not repeat the definition of the SNARC, but just some things that people already did with the SNARC in the last 20 years. Most of them are sitting here. So you can hunt the SNARC. You can even, after that, quash it, as it takes just one word to quash the SNARC. Cook the SNARC. I will talk about these two papers later. Then you can modify it to SMARC, Spark, Stark, etc. And this is just some modification that researchers continue following the SNARC effect. So where does it come from? So Dehaene, in his 1993 experiment 7, just showed that Iranians who habitually read from right to left and recently immigrated to France show a weaker SNARC effect compared to Iranians that spend more time in left to right surrounding. Zebi in 2005 found that Lebanese participants who read from right to left in Arabic script show a kind of reverse SNARC effect in a verbal naming task. So they had to name the larger number, and they did it faster if the larger number was on the left than if it was on the right. However, the above two studies did not test the possible differentiation of reading direction of words and reading direction of numbers, because in the Western culture, for example, you read text from left to right, and you read numbers, the number line or the mental number line also goes from left to right. So luckily, we found 3 groups of different reading habits for words and numbers. Canadians or Western participants who read text from left to right and numbers from left to right. Palestinians that read Arabic from right to left, and at least in East Arabic digits, they write them, they study them in school from right to left, 1, 2, 3, 4, 5, etc. And a mixed group of Israelis in which they read text from right to left, but numbers from left to right. And we run a parity task, and here's the results. You can see the typical negative slope, the typical SNARC effect for Canadians, a reverse SNARC effect for Palestinians, and a null effect, no SNARC effect for the Israeli group. So this means, these results suggest that both reading habits of numbers and words contribute to the SNARC effect. If the SNARC effect emerges from reading direction habits, we suppose not to find it with preschool children that did not start to, that did not have any reading experience. So what is the developmental trajectory of the SNARC effect? So we cannot use the parity task with preschool children, but we run a counting task in which we ask adults, children, school children and preschool children to count 4 coins and point at them. So just 1, 2, 3, 4, or the vice versa. And here's the results for the adult participants. So most of the By the way, this, we run this experiment collaborating with Silke Gubel from York University, and we found that most of the English participants started to count from the left, 1, 2, 3, 4. However, the Palestinian group started from the right, 1, 2, 3, 4. Again, the Israeli group, as well as a literate group of Ethiopian people that immigrated to Israel, did not show any preferences. This is not significant. So it's similar to the pattern we found with the parity task in the SNARC effect. Let's see what's happened with the children. So as you can see here, even preschool children, this is the English preschool children, they have, most of them started with the left. And this bias increases with reading experience in school. The same pattern, the opposite pattern for right to left Palestinian preschool children, that most of them started on the right. And this effect, this bias was increasing with school children. However, the only group of participants that show weaker counting bias after reading was the Israeli group, that preschool children show a clear right bias. However, with reading experience, the effect was weaker. And I must give the example of my two kids, that my daughter, when she was 4 years old, I put 4 cookies, so I cannot use her results. This experiment was with coins, but 4 cookies, and I asked her to count in front of my older child, so she counts from right to left, 1, 2, 3, 4. And Jonathan, my older son, said, no, with number, you should start on the other direction. I have a video, I don't know why I didn't embed it here. So far I reviewed the long-standing reading habit. What about short-term changes? So here's the effect of current reading direction. We asked bilingual Russian and Hebrew participants to read Hebrew or Russian text, and we found that the SNARC effect was reduced after reading for 15 or 20 minutes Hebrew text. So they show SNARC effects after reading Russian or Hebrew, but it was reduced after reading Hebrew text. And what about the word level? How short is the short-term memory? So in this experiment we ran also bilingual Russian and Hebrew participants, and we asked them to perform parity task of Arabic digits and Russian and Hebrew number words. So here's a demonstration of the experiment. So you see a Russian number word followed by Arabic digit, then Hebrew digit, a Hebrew number word, and Arabic digits. And here's the results. So for number words, so they show clear SNARC effect, that it was reduced, it was not significant actually after when they performed the parity task of Hebrew number word. Moreover, the effect, the manipulation works for the Arabic digits that followed number words. So if they performed parity task of Arabic digits after judging a Russian number words, they show SNARC effects, but a reduced SNARC effect for the same Arabic digits if it was preceded by a Hebrew number word. Another manipulation of short-term changes is the effect of number position during reading. So we compare between, so participants, we used English and Israeli participants, and we asked them to read text in English. The English participants read English text, the Israeli read only Hebrew text. So you can see here, we asked them to read 20 or 22 fake recipes. Don't try it at home, please. And we ask them questions after each recipe, so they have to remember everything, including the numbers. And as you can see here, this is the incongruent condition in which they saw large number on the left and small numbers on the right. So they read 20 or 22 recipes that all of them were congruent or incongruent with the number line. And here's the results for English participants. We compare between the pre-test and the post-test. So when the numbers were congruent with the number line, we found the same SNARC effect before and after. However, the SNARC effect was disappeared in this condition. So we are talking about participants that read from left to right, and numbers also usually go from left to right. But however, in this case, in the short-term memory, they have small numbers on the right and large number on the left, and the SNARC disappeared. Here's the Israeli results, no SNARC before and after for the congruent condition, and we found reverse SNARC effects when it was incongruent. This is incongruent with the number line for Israelis as well. So when Hebrew speakers read text from right to left, and they have the numbers, small numbers on the left and large number on the right, it generates the reverse SNARC effect. Finally, what about the key position? So we ask Israeli participants to perform horizontal and vertical SNARC. Actually, it's not vertical, it's radial because it's near and far on the computer, to run a parity task in separate blocks. And we found no SNARC effect. It is not significant, no SNARC effect for the horizontal condition, but a clear SNARC effect for the radial or vertical condition. So even Israelis can show SNARC effects when you take the conflicting dimension out. So in conclusion, we believe that multiple spatial dimensions are involved whenever we observe SNARC effects, like the long-standing spatial habits, reading habits of text, and observation of spatial habits of preschool children that probably learn from their parents reading text from left to right or right to left. And short-term experience like current reading direction or a number position. And finally, we believe that everybody SNARCs, means that there is a general tendency to map numbers onto space. And in case of Israeli, for example, you don't see it in the horizontal dimension because you have conflicting directions, but however, in a vertical or radial dimension, you will find the SNARC effect.
Okay, so Sam has described to you our research program, which was trying to tackle a particular question: where does SNARC come from? And you could see that this approach led to ever more detailed questions. One answer raised further new questions. That's how science progresses, and that's good. But I want to take a slightly different approach as I proceed in this presentation, and I would like to step back from this hunt of the SNARC and try to look back at those 20 years of research that we all and other people have conducted, and try to discover some lessons that we might learn from this kind of investigation. So I will talk about conceptual aspects of SNARC. The picture here is a different variant of the one that Stan presented earlier, you can see there is a substantial amount of references to the original Dehaene, Bossini, and Giraud paper from '93 over the years. There is substantial increase in the last 4 years. So now we are at the level where every year there are between 70 or 80 citations to this work. Is this a lot? It's hard to say because we all know it depends on how big the field of researchers is who are interested in a particular question. So to illustrate, I'll give you two comparisons. One is to a famous paper that I'm sure all of you know, the 1971 paper by Shepard and Metzler that appeared in Science and reported the mental rotation effect. This is something everyone who studies cognitive psychology and human cognition learns about. And this paper is cited about 20 to 30 times a year, even though there has been a long debate about the imagery processes and the nature of knowledge representations. So only half as much interest was induced by this particular paper. Yet it's very interesting because it shows you that when we try to manipulate knowledge representations, we have to follow physical constraints that are present in our environment. So that's an interesting result to which I will refer back. Another comparison is to a paper that is actually cited 70 to 80 times, that was cited 70 or 80 times 20 years following its original publication, and that's another one that all of you will know. It's one of the foundation papers in cognitive psychology and cognitive science, and it has to do with numbers. It's the magical number 7, plus or minus 2, by George Miller from 1956. And so this is now cited over 6,000 times in total, so there's hope for the SNARC to be a foundation paper, possibly, if we can manage to draw the right lessons from all this research that has taken place and will take place in the future. So what are some of the patterns that have emerged from this kind of analytical approach? Of course, in the early years, people tried to generalize the effect, and there is a nice review in 2008 published by Guillaume Wood that summarizes the early stages of that and reports that the SNARC effect generalizes across many different tasks, many different effector systems, and that's why I suggest we should talk about spatial numerical associations in general. For example, you do not need to select one or the other response, and you will still find that your behavior or the behavior of your participants is influenced by this pervasive association between number, magnitude, and space. It's something that characterizes the way we seem to represent our knowledge. We refer to space in order to retrieve knowledge. Another pattern that I have found when I look back on those 20 years, and that's maybe a bit more idiosyncratic, has to do with modeling. So some of the people interested in the SNARC effect came up with computational models and made proposals of how to implement architectures for cognition that generate this performance signature we call SNARC. A surprising thing is, though, that all these models basically remained focused on trying to understand the SNARC effect and the signature, not moving beyond this and trying to address the broader perspective of how numerical cognition works. And that's, I think, surprising given the fact that the original paper by Stan and his colleagues actually set out to test 4 different models. They are shown here in this little graph. So the original attempt was to try and understand how parity could be represented in each of these 4 different models of how knowledge is represented in our minds. So I think that's where we should go back to after these first 20 years, and the rest of my talk is meant to inspire the many people, the young researchers here and others who see the movies eventually, to ask the right questions. And I hope we debate throughout the day today and in the future whether the questions that I will pose later are the right questions. They are leading in the direction of embodied cognition as a possible way of integrating the many findings. You have heard various moments during Stan's talk, and also Sam has presented data where it became clear that bodily action seems to be quite important. The way we are positioned in space influences the spatial numerical association. If you are resting on your back, space seems to be discounted because it's an unusual position that your body is in. Several other findings to do with different effector systems also show that the spatial numerical associations are quite sensitive to the current performance requirements. And the sketch that I'm showing here is taken from quite an influential theoretical proposal by Friedemann Pulvermüller and his colleagues, who proposed that all our knowledge remains associated with the sensory and motor features that were present when we acquired that knowledge. That's the core statement behind embodied cognition research. And it's illustrated in this sketch here, where knowledge representation for an action verb, like to kick, or to pick, or to lick, is represented in a distributed fashion that includes not just temporal lobe nodes, but also extends in the motor cortex, and particularly into that area of the motor cortex that would control the body part that does the kicking, or picking, or licking. That's the idea of a semantic somatotopy, which was recently confirmed and replicated in the domain of numerical knowledge, where Nadia Tschentscher worked in the Pulvermüller lab, and she invited people who start counting on their left hand and people who start counting on their right hand into the scanner, and they were passively viewing small numbers or number words on the screen. No response was required. And we found that the left starters activate their right hand motor cortex when they see small numbers. And that's the idea behind the semantic somatotopy. So embodied cognition may be a very promising approach, and that's where I want to draw attention to. I want to propose a hierarchy of spatial numerical knowledge. So the different research programs that people have directed toward the SNARC effect have always led to differentiations. And so I think at the fundamental level, it seems plausible that there are certain universal constraints that operate on cognition. These are constraints that we all share, regardless of which culture we are in. For example, we are all experiencing gravity. We all expect light sources to be above. We all have to acknowledge that two objects cannot share the same place at the same time. These are just physical limitations that have also shaped the evolution of our nervous system. In the case of numbers, the prediction of this particular view is that the horizontal SNARC effect, which we have been talking about so far, is actually not the strongest indicator of this spatial numerical association. From a grounded perspective of cognition, the vertical association is the universal one, because regardless of which culture you live in, the more objects you accumulate, the higher the pile will be. So small numbers should be associated with the bottom and large numbers with the top. On top of these and other grounding constraints is the embodiment of cognition. This is where sensory and motor features come into play, your individual learning experience, how you interact with objects in space. And a good example is the work by Michael Andres and colleagues, who asked people to make parity judgments, not with button presses, but by changing their grasp aperture from an intermediate opening either into a grasp closure or a grasp opening. And so the odd or even responses were made for small or large numbers by either opening or closing your initial grasp aperture. And the result they found was that you can close your hand faster in response to small numbers, and you can open your hand faster in response to large numbers. This is an indication of a sensory motor constraint that we all have experienced and learned, because we pick up small objects with a precision grip and large objects with a power grip. And there are many other examples. The scanning habits that Sam and I investigated for a while are part of this, the cultural associations. And they're more flexible. They are less stable than these grounded constraints. And on top of this, you've already heard some examples, and there are many others, of extreme flexibility of the horizontal spatial mapping. These are task-specific constraints. They are set up because of the current instruction that you have to keep in your working memory. And Wim Fiers will talk after me about this particularly strong influence that working memory constraints can have on the way you map numbers onto space. This, I think, is also the reason why if you test people repeatedly, you tend to find relatively low retest reliability of the SNARC effect, because in these studies, typically there is not enough constraint imposed on the way people have to deal with these tasks. So the horizontal association is relatively flexible. And also the correlation between the SNARC effect and mathematical ability doesn't seem to be particularly strong. There's a debate. This is one of the current debates that are being fought in the literature. And I think if you realize that the content of your working memory is flexibly set up to deal with particular constraints, you can appreciate why that puts a limiting factor on the strength of that relationship. Okay, how much time do I have? Okay, so just quickly to illustrate, the prediction of this approach is that the vertical SNARC effect is the one that we should concentrate on. It's the more profound association between numbers in space, and it should therefore also be harder to untrain or to change. In real life, you can experience two different vertical mappings on the top, and circled in red is a mobile phone type of mapping, small numbers at the top. At the bottom, the numerical keyboard has the small numbers at the bottom. So opposite mappings. And when people come into the lab, and this was an experiment done several years ago by Peter Kohlmann, who visited my lab when he studied in Ghent. He invited people into the lab. They had vertically arranged keys, or radial, I should say, to make the odd-even judgment. And we classified people in those who spontaneously have small numbers associated with the top, circled in red, and those who spontaneously associate small numbers with the bottom, circled in green, which is the grounded mapping. And the prediction of this particular embodied cognition approach is that the people in green, they should preserve that mapping regardless of the training. The training was always a data entry task that imposed working with the opposite mapping. So the people from the green group had to enter data according to the red layout. The people from the red layout, from the red mapping, had to enter the data using the green mapping. So we were trying to get rid of the initial and spontaneously documented vertical SNARC. And we measured this during various stages during this training, which was quite long-lasting, as you can see, over a whole day and also on the next. Yet only the grounded mapping, the green one, where small numbers are at the bottom, only this mapping persisted and was not changeable, whereas the other one was more liable to be changed. And that's the kind of data that I would like to see more. This is important to address, whether the learning gradients differ for these different levels of knowledge representation that I have introduced to you. So to conclude and to foreshadow the next anniversary meeting of the SNARC researchers, here are two questions that I think are worthy of attention. One is, already mentioned, whether the SNARC effect that was so far documented largely with single digits extends to more complex arithmetic operations. And this is the operational momentum effect. We've heard about it already. It has implications for arithmetic teaching, because finger counting may actually be a very valuable tool that should not be suppressed, because it enriches your conceptual representations. Even in adults, these representations are still equipped with sensory and motor features. And that's the kind of question that Sam Shaki and I would like to address in a special issue. So speak to him or to me during this meeting, or contact us to find out more about this plan to have another special issue to advance and focus the research in that direction. And the second point is addressing the notion of a hierarchy. The question here is whether the learning or unlearning of spatial numerical mappings will differ for these different levels of knowledge representation, the grounded, embodied, or situated spatial numerical associations. This is the kind of work that we are doing in Potsdam at the Potsdam Embodied Cognition Group, and this is also the kind of work that we would very much like to see at the forthcoming ESLP meeting, which will be held in Potsdam in July of this year, and for which you can still submit your interest. So thank you very much for your attention, and we now look forward to your questions.